Hey guys, thanks everyone for joining. Welcome everyone, and we are also live streaming. We should be watching us on LinkedIn and YouTube as well. If you have any questions, feel free to post your questions both on LinkedIn and YouTube as well. So we can take it from there. And let me give you a brief introduction for InferX. Let me share my screen for a second, and then we'll go from there.
So InferX is a true serverless inference platform. What I mean to say by true is we bring sub-second cold starts to even 32 billion parameter models. That means you will have on-demand access to your model within a couple of seconds, and you can scale to zero immediately once your inferencing is done. What that means is you will only pay for the execution time, no model loading time and the idle time charge here. So what it means in theory, in practice actually, means imagine you're having to rent a GPU, for example H100, 24/7 just to avoid that cold start latency, right? And you will be paying about $3,000 per month, whereas on InferX, you for the same model you can have the on-demand access within a couple of seconds, and we can scale to zero immediately, and you will only pay for the execution. That means you're only paying for the execution time, which is about $120. So look at the difference: $33,000 versus $120. So that's about 25 times savings. And the other part is InferX has two products. One is InferX in Inference Cloud, which is basically developers can deploy their models and then can have on-demand access to their model anytime they want without having to pay for 24/7 GPU. And there's an InferX platform as well, and the same technology that we use that can also be deployed on your on-prem cluster as well. You can be a neo cloud or an inference provider if you want to enable serverless inference on your platform with sub-second cold starts. You can deploy it on your own cluster and without any stack change basically. So this can sit on your right on top of your Kubernetes cluster.
So with that, so today's session is going to be involved some technical deep dive with my co-founder here, Brad. Brad, who is also a ex-chief architect of Huawei Cloud. He's the co-founder of InferX. He's been working on it for almost 6 years of time building InferX. So this is not any wrapper or any of that sort. So this is a system re-engineering completely put together from the scratch. And also meet Jason. Jason is also one of our co-founders. He was an ex-principal architect for Microsoft Azure. He comes with 15 plus years of runtime engineering and system engineering at the low level. So with that, I would love to welcome you all to, and yeah, again, if you have any questions, please feel free to post it on LinkedIn and the YouTube as well. And we will be posting it afterwards, so you will be able to watch it later on as well if you're missing the live. So with that, I will take it from here. And Brad, thanks again for joining. I know Brad is kind of a person, he doesn't like to be on the camera, but I really forced him to be on live right now. He's a kind of timid person, but he's an engineer, obviously. So, but this is his first time probably going public with InferX, and then we are the team behind InferX. And Brad, thanks again. Let me start with a couple of questions. I know you are a chief architect at Huawei Cloud, and you've been building a CPU-based workloads for almost 20 plus years. But now we are on to GPUs, right? The serverless, we're exclusively talking about serverless here. So serverless might work for CPUs. It worked, AWS Lambda did a great job when they introduced that and bringing serverless into CPUs, where multiple users can share the infrastructure and they can deploy their workloads on demand. But when it comes to GPUs, it's a completely different mechanism. Could you explain why it is so different?
Okay. Yes. Yeah. Let's first define what is a serverless. Actually, serverless start to be popular maybe 10 years ago when the AWS released the Lambda. At that time, Lambda just serverless could be just we can think it just equal to the function as service. That's it have two major characters. The first one is on-demand serving. That means when this user request come in, serverless platform will start the instance to serve this request. And another character is that it will scale down to 0. That means when there's no request, the platform will terminate all the instance to release the resource. Based on these two characters, that's user's service don't need to waste resource when this idle, so that customer can just pay for the serving instead of pay for the idle. That's the major purpose of the serverless. Yeah, serverless heavily rely on the cold start for the user experience. For the CPU world, for the lightweight CPU work-based application, it's easy to achieve sub 1 second cold start. And even for the heavy CPU workload, it's also easy to optimize that to cold start in less than a few seconds. But for the GPU application, cold start latency could be more than 10 seconds, very easily to almost all the GPU workload will be almost more than 10 seconds and will go to tens of minutes. And this slow cold start block serverless in the GPU world.
Yeah, that's a great point, actually. So you mentioned the cold start area, right? Yes, for the CPU workloads, they're very small. They're mostly web-based applications there. It will be easier to probably cold start immediately. But why is cold start so important and such a critical problem here for GPU serverless? I mean, what exactly breaks here? Could you please explain it in the terms?
Oh, yes. Actually, compared with dedicated service, serverless can save the customer's cost just based on this on-demand manner. But when user first request come in, it needs to do the cold start to start the instance to do serving, and this cold start latency might hurt the user experience. If the cold start latency is very high, user's experience will be very bad or maybe useless for the customer. For example, for the inference scenario, the common time to the first token is about a few seconds, maybe less than 5 seconds. But if the cold start latency is 30 seconds, well, what is the user feeling? He may feel that the service already done, and he maybe just go away or resend the request. And it's not a bad experience. Actually, they make this service useless. So the cold start is so important for the serverless.
So you're basically saying unless you achieve quick cold start, you can be true serverless. Is that right? I mean, unless you have a like near zero cold start, you can be true serverless. Is that what you're saying?
Oh yeah, actually, for the serverless serving, the major technical challenge is to decrease the cold start,
Right.
not only for the CPU serverless and GPU serverless.
Oh, they're combined together. Okay, got it. So that leads us to, let's see. I mean, so what exactly is happening during this cold start time especially for the large models, right? Right. I mean, why does it take so long for a model to load into the GPU? Can you please explain like what's going on during this time?
Yes. For the inference with a large model, actually the cold start latency include two major part. The first part is easy to understand. That's the model loading. You know that's for the model-based inference, then model size could be for the small model it is a few GB, and for the large model maybe it's 100 GB data. In order to serve before the model can serve the request, all the model data need to load it from the source to the GPU memory. Depends on the source bandwidth. For example, if the source is in the remote store S3, the bandwidth is a few hundred megabytes per second. Even that in the local disk, that is a few GB per second. It will take maybe a few seconds and to 10 minutes to load the data. To load data to the GPU memory. Yeah, this is the first part for the latency. And the second part is from the framework initialization. For example, when we use VRM, for the inference. When VRM first start, its initialization will need to be done. It's include, for example, initialize the graph or do the create the CUDA object like the stream, like Cooper Plus, this kind of object. Maybe sometimes they also need to do compilation for the CUDA kernel. It will take tens of seconds. Yeah, add them together. This first is model loading, another is framework initialization. It will take tens of seconds to do the normal cold start. Yeah, and because this two process is totally different than the CPU-based workload and much heavier than the CPU workload. So traditional that's the CPU-based optimization is hard to cannot be used in this area and cannot decrease cursor latency for GPU application.
Great, but it looks like, but still, people are still working around this CPU mechanism. Still, so what are the most like current industry standards right now to achieve this cold start latency problem? Or what are some? I mean, there's so many serverless out there as well. They're trying to optimize around it or work around it by either provisioning the GPU, or they're probably calling it just deploy loading the model and calling it a cold start. But so what are the current standards in the industry? What have you seen?
Yeah, industry actually spend much effort to optimize the GPU-based workloads cold start. This also they will happen in the academic or in the industry. For example, the most simple one is to optimize the model loading. They copy the model data from the remote store to local disk to accelerate the model load latency, and but it can still cannot make this latency to a satisfied range. And as we talked just now, and for the inference workload, there's a hard requirement for the cold start for the inference latency. For example, maybe this latency is 5 seconds, maybe it's 10 seconds. If the cold start latency cannot reach that range, that means user cannot bear that, and we have to make a service as a always on service, just pre-provision that and pre-warm the instance. Yeah, that's a major solution to mitigate this issue. And in the industry, there's some serverless inference service, and there's a major mitigation that to handle a special configuration that is the scale down window. Scale down window means when for the standard serverless, when there's no requirement, no request, we need to scale down to 0 for the instance. But in order to mitigate that, user will make a very large scale down window. That means, for example, for 1 hour, that means when there's no request, the system will wait for 1 hour window before terminating the instance. If there is a request coming in this 1 hour, request will be served with the warmed instance immediately without cold start. So from user point of view, it just gets a very quick cold start. Actually, it's warm start, not a cold start. But
Yeah.
actually, this mitigation have two problems. First, that customer have to pay for this 1 hour idle time. Actually, this is a violation of the user requirement and expectation for service.
Right.
And the second issue is that if there's no request coming in this window and the instance is terminated, next request will trigger the cold start, and the user will suffer from the cold start latency,
Right.
and it's very bad user experience.
Right. So that is the reason they just keep it provisioned so they can avoid the cold start, basically.
Yes.
And with that, this also leads to basically the GPU utilization as well, right? So the GPU is just sitting idle, and the most of it is just being wasted. Right? Is that also a problem as well, right?
Yes, yeah, because we cannot scale down to zero when there's no request, and we have get the GPU application warm, and actually they occupy the GPU and they just cost the GPU price, and actually for this kind of large scale down window, somehow it's just like the always on service. It's not a real, it's not a true service.
Serverless, exactly. I know there's a lot of confusion out there. I mean, even when I talk to some developers, I mean, people call it OpenAI serverless.
Oh,
Or
yeah.
how do you say that actually? How do you answer that?
Yeah, just like we talked that in the traditional cloud area, serverless is clear, just that's on-demand serving. Just we call it Lambda serverless, and then there's a serverless container, just like Fargate in the AWS.
Yeah.
But when we go to inference world, they call it something just like OpenAI. They call it serverless and kind of pay for token as serverless.
Yeah.
Actually, this word become weird and
I know.
overused. Yeah.
It's become so serverless became very vague wording out there. Yeah, that's great. And but that's where we come to InferX. I know you've been working on this problem for almost 7 years now. It's over 7 years, and you've been trying to mitigate this cold start issue. And I've seen it. How is InferX changing this? Basically, how are you trying to solve this cold start issue? What is happening under? How are you able to mitigate this cold start issue?
Yeah, actually, InferX solves this problem by create a new snapshot-based cold start. Actually, this is InferX first introduced this kind of cold start optimization in this industry. Based on this snapshot-based cold start, that's when user submit this model, InferX will first run the model just like a normal cold start. And when all the normal data is loaded to the GPU memory and the inference framework initialization finished, and the instance is ready to serve the request, InferX will create a snapshot based on the GPU state and the CPU state. And after this snapshot is stored in the storage, any new request will be served based on this course snapshot, and so that we can bypass the framework initialization. And with this cold start mechanism, and we can achieve very fast cold start. For example, for a 32B model, that is 64 GB model data, we can do the cold start less than 1 second. This
Wow.
is yeah, in the industry, actually, it's very hard to find a cold start for a model less than 10 seconds, and we can achieve that in 1 second. And uh, and we can also give different level cold start based on user requirement. And this cold start latency is acceptable for majority of user scenario, so that we don't so that there's no need to keep a large scale down window. Based on that, customer don't need to pay for the idle GPU. It will save a lot of budget for the customer.
Wow.
And yeah, for example, if you have a model you want to get it online for the agent, you want to serve that online. Uh, Maybe before there's only one way to do that, just rent a H100, for example, H100, and then serve that. If it's H100, it's $3 per hour. To keep a model online, it takes about 2,000 per month if you want it always online.
Right.
And with InferX, maybe just $100 can keep
Yeah.
it online.
So basically, this is probably good for especially the bursty, spiky workloads. Where you don't have to keep the GPU, where you don't need the GPU 24/7, and your requests are coming only maybe 9 a.m. You probably have 10 requests, or 12 p.m. you have 0. So where GPU utilization is probably around like 5 to 10%, and that is exactly where it's beneficial. Is that what you're saying?
Yes, because we have very quick cold start, so we can truly handle this on-demand request. Yeah.
Wow, that's amazing, actually. And okay, so with that, actually, we will move on to demoing the InferX new UI. It's still under under construction, but we recently released it, but it's still in private beta, and our chief engineer Jason will demo it, how exactly it works and how simple it is to deploy your model and get on point endpoint in about like 2 minutes. Jason, could you please show us?
Okay.
And also, if you could please also show us that the Brad was talking about the 32 GB in 1 second. Is that really true? Could you please show us? And we would love to see it. I think you're muted, I believe.
Can you hear me?
Yes, now, yes.
Okay. Can you see my screen, right?
Yes. So this is where you log in, or what is this? This is the dashboard.
Yeah, this is the new dashboard of InferX. Let me.
So this is what you see once you log in, or can you start from login, or this is fine, I think, yeah.
Yeah, this is like the default page when you log in our InferX service.
Okay.
So here is the model list you have. So I already deployed the Qwen 32B here for the cold start demo. But before that, I want to go through how you can create your model like from the very beginning.
Okay, please.
So yeah, you have a button here. When you click the create model, go to the model creation page. So here you can select like the mod. This is the model alias, in fact. Here is you can select the Hugging Face model ID. So for here, I just use the Qwen 1.5B. So after that, you can like change some settings. Like you can feed different VLM parameters here. Also, you can select different version of the VLM image. I mean, for different model, you may need one GPU or two GPU, or even like four GPU. But here on the UI, we only open like two GPU. If you need like four GPU, you can click this button to contact us.
Great.
Also, for this model, yeah, I just use maybe the 13 gig for the VRAM. We have some advanced settings, like you can select the queue timeout and also the screen timeout. Now I just use the screen timeout as the default.
Okay.
Yeah, with this, you can just see the model. So you can see here, after you create the model, InferX will try to create a snapshot for this model. For this one, it takes about like 3 minutes. I mean, while we are waiting for the snapshot creation, I can show you like how fast our cold start can be.
So basically, right now it's creating the snapshot in the background. The user doesn't
Yes.
have to touch anything, no coding, no SDKs, nothing to follow, basically.
Exactly.
Oh, great. Okay.
So here you can see we do not have a warm pod for the Qwen 32B. It's just in standby mode.
Oh, it's standby. So
Yeah.
it's currently not in the VRAM. It's sitting in
Exactly.
the CPU memory. Is that right?
Yeah.
Okay, great.
It doesn't use any GPU now.
Okay.
So on the dashboard, you can go to the model here. You can like send the inference request. Yeah, it just works. So here you can see totally it's like less than 1 second.
Wow, that's
Yeah,
about less than 1 second. So this is a full model. It's not quantized.
Yeah, it's full model.
Wow. So that's almost 64 gigabytes of memory. That's what you're talking about. Huh.
Yeah.
Wow. Okay. So that's 1 second cold start for sub-second cold start for you guys. It's a 32 GB model, a 32B model, 64 gigabytes of memory, and in 1 second we can bring it to the VRAM. Wow! Thanks again.
Yeah, now you can see it's in ready mode. So that means that if you send another request.
Oh, it's already sitting in the VRAM now. So can you show
Yes.
the warm start actually? How long it? Let's see.
Warm
start.
Sorry.
Since it is sitting in the VRAMs, can we also show the warm start?
Oh yeah, that's what I was.
Oh, that's even quicker now because it's sitting in the VRAM. Okay.
Yes.
Wow.
So now we can go back to the pods page. So you see for the newly created model, is still doing some snapshotting. Basically, it will load the model in memory and do some snapshotting itself. So while
Oh,
waiting for the
you can also
snapshot,
look at the logs while it is snapshotting, right? Okay,
yes,
great.
yeah,
Okay.
it's a log from VLM. So at the same time, I want to show you some other pages. So as a customer, you can go to the admin page. So here you can, we have a billing page. Here you can see like how much, I mean, you have with your current balance. Also,
Okay.
like how much time you used, both for inference and standby. Also,
Nice.
you can, yeah, we can have another action called usage analytics. If you have like multiple models, you can see like how much time used for each models. You can select different time range.
Nice.
Yeah.
So basically, you can monitor your inference usage, and most importantly, you are only built for the execution, right? So basically, from the prompt given to the end of time, end of token generation. So like
Yeah.
15 to 20 seconds. So nothing in between. I mean,
Mhm.
there's no idle time. There is no cold start time. Nothing.
Yes. When you see this, you can like get a drill down, so you can see in each hour like how much time inference standby you use and also the money you spent.
Wow. Okay, that's great. Yeah. So it's pretty much like Lambda. It looks like, right? Like
Yeah,
AWS
exactly.
Lambda. Oh,
Mhm.
amazing. Okay, that's great. Yeah. Can we go back to the pod? Is that right? I mean,
Yeah, another thing I want to mention is because each customer will have its own tenant. So that means uh, any model you put in your tenant will not be visible to other customers. So it's our isolation layer.
okay.
That also means like for this model, uh, I mean, not only you can do the inference on the dashboard, you can also we provide some sample code example for you to like construct your own request.
Mm-hmm.
Here for model in your tenant, you need to specify we call it API key here. So during the onboarding, in fact, we create a key here. So you can copy the API key and fill in the code example. It will work that way.
Okay. Got it.
Yeah, let's go back here. Yeah, now you see our snapshot is created.
Oh, already. So it took about like
Yeah,
2 minutes, maybe. Yeah.
yeah. Let's
Let's
go
try
here.
to load the model and
Mhm.
see.
When we
So
go to the
guys,
model page.
we literally just deploy this model
Yeah.
while we are waiting,
Mhm.
and then the snapshot is already created. Now we can just use the endpoint, right?
Yeah, exactly. So here also after you create the model snapshot, we have log here, so you can still see the logs during the model snapshot creation. So
Okay.
you can see all the VM logs. Like sometimes for some large model, maybe you did not specify large enough VRAM or something. You can get some information here. Also, you can get some information here. So
Right.
now, since the model snapshot is created, we can just click the inference. Now, yeah,
Wow.
it
Oh,
works.
that's amazing. So
Yeah.
it's about like 0.2 seconds. So the model is ready to use right now already.
Yes.
Wow. And also this is, I understand this is a very small model, looks like 1.5 billion parameter right here.
Mhm.
But what about the bigger models? So they can also deploy bigger models as well, right?
Yeah,
Yeah.
sure. Yeah, they can. You can use whatever model because when you create a model here, you can select like whatever model you like using the Hugging Face model ID.
Yeah.
Also, you can maybe for some big model you need 2 GPU, just select 2 GPU, and
Yeah.
you can select some bigger VRAM.
Got it. Got it. Okay. And okay, this is for, I mean, for Hugging Face models, yes, you can copy and paste it here and you're ready to go. What about somebody has some custom model or they want to bring their own Docker image? So how about that? Can we also do that as well?
Yeah, sure. But currently, because we're still in some beta stage, so
Right.
we give a whitelist for the images.
Right.
You
Okay.
see, we already have an option when you use a VM Omni model. You can also specify here. If you do not
Oh,
have the list, I mean, your image in the list, you can just click the support button, go to
Okay,
our community, just
got
contact us. We can either deploy to you or find some other way to deploy the model.
okay. So it's also good for email Omni models, is like a TTS or QuintTTS or like image models as well. Okay, great.
Yes.
And what about if somebody wants to bring their own container? Can we also do that as well?
Yeah, we can. But it's not spotted on the dashboard yet, but if you can contact us, we can make that happen.
Great. Wow, this is great. Yeah, thank you so much for the demonstration here. Yeah, that's very lovely. With that, guys, we do have some questions here, and Brad has been trying to answer them. But let's quickly go back to Brad as Brad, if you could please answer them in person as well, that would be great.
Yeah.
Let's see what's going on. Where are the snapshots stored actually? Is there multiple places for the snapshots to be stored, or?
Oh, actually, snapshot is stored in the SSD, and if user just configure the in-memory cache, and before the user quite come in, the snapshot could be loaded to the RAM so that it can get the fast cold start. If user didn't configure that in-memory cache, that will always in the SSD. Because InferX system have a very fast SSD system, it can yield 20 GB per second. That's read latency.
Wow.
So for
Did you
for
just say
the
20 GB per second?
yes,
That's crazy. Okay.
yeah, and for a model with two H100 GPU, that's about that's less than 140 GB model
Right.
data, and we can do the cold start even from SSD with less than 10 seconds.
Right, thank you. The next question is like, how often the snapshots start being restored? The follow-up question is, it says, what data is being stored in the snapshot? What is exactly in the snapshot?
Oh yeah, actually snapshot is created when user submits the model, and we will start a snapshot run and just save the snapshot, and the snapshot will be saved in the SSD, and it's one-time work.
Okay,
And the snapshot itself includes two parts of data. One is the CPU state, another is the GPU state. All the GPU state include that model data and the KV cache. Yeah,
great.
all of them is yeah.
So basically, the entire state is included in the snapshot. So not just the model or the weights. Okay, that's great. Okay. There's another question is, and when the system upgrades are happening, like kernel CUDA drifts, because of the patches upgrades, do you fall back to cold start?
Oh no, actually, if users application have some changes just for some system upgrade, user should submit a new container image or a new model, new node name, just update the model name, something like that, and the InferX will create another snapshot based on that.
Oh, interesting.
Yeah.
Okay. Oh, that's good. And somebody has this is an interesting question actually. Is the stack built similar to CRIU, GPU type of stacks? And also, can it in the near future also do non-LLM workloads like image custom containers, etc.?
Yeah, actually, snapshot is just like the CRIU. The difference is that the CRIU, that's the GPU CRIU is supported by the NVIDIA, and they create that. And we create snapshot by ourselves in our software stack. Based on that, we can have this sub 10 second, sub 1 second cold start because we fully own this software stack. We can do all the optimization for that. Yeah.
Oh, wow,
Uh,
that's great. Yeah, okay, sorry,
yeah.
please go ahead.
Yeah. So what's the next question? Sorry, I forgot.
Yeah, I mean, is it similar
Oh,
to CRIU? And also, do you also support non-LLM workloads like image custom containers and etc.?
oh yes. Actually, by default, we support that. Just the current system, we have some limitation from the user interface, and but in future we will support that. Actually, for the non-VRM, non-VLM workload, we already support that. In our system, we support some TTS model that's non-LLM workload.
Not VLM workloads as well.
Yeah, OCI, etc. Yeah.
OCI infrastructure. Also, and a question from myself, actually, I know we are using the VLLM under the hood for the inference as an inference engine. So is InferX going to support other frameworks as well, like SGLang or TRT-LLM in the future?
Yeah, so far we didn't support that, but in future we will support that.
Okay. Okay, we have another question here. Modal, how is it relevant to modal? Modal also trying to do some kind of a GPU snapshotting. Oh, interesting. Okay. Do you want to get on that? Or I can also answer that. Basically, yes. I mean, modal is. I mean, it's an amazing team. They're actually one of the few guys in the AI infrastructure arena. They're doing some great job. We've also briefly worked with them. I'm not quite sure what kind of a GPU snapshotting they're doing, and but I mean, we would love for you to try both of us actually. Try model and ourselves as well, and check the cold starts and see what's the difference. But we haven't we've only looked at the documents. I think it's based on the CRIU, I believe. That's what it goes back to, the NVIDIA CRIU checkpointing. But yeah, please try us both and see. We also have some free credits for you to just try it out and see what is the difference between the other serverless and InferX. Yeah. So there is another question. This is in the latest NVIDIA GPU architecture. I don't think so. Is that right? Is NVIDIA?
We support H100, B200. Yeah, we test that.
Okay, so basically any NVIDIA hardware, so we can support right now.
Yeah, we test in majority that's NVIDIA GPU.
Okay, that's great. And what about other GPUs though? I'm just curious. I mean, is this a hardware agnostic? I mean, I know we only support NVIDIA GPUs now. What about the future path? How is that looking?
Yeah, so far we only support NVIDIA GPU, but we can support AMD and AMD GPU in future.
Okay, great. There's one other question is, what is a restore path? Is it going from SSD to CPU to PCIe and then the GPU?
Actually, so far we are using NVIDIA GPU direct storage to load the data from the SSD to the GPU memory. It will bypass the CPU. The path is SSD to the PCIe to the HBM directly.
Oh, interesting. Okay. And how does it work? I mean, across the cluster? Yes, I mean, for multi-node especially, or have you tried that as well? For single GPU, this looks great, but what about the multi-node and across the cluster level? Could you please explain that?
Yeah, we support multiple node, and we also support multiple node scale in, scale out for the user. If they have one GPU model, if there's a burst request, they need more than 8 GPU, and that means the workload will be scaled out to multiple node.
Great. Okay. There's another question is, there's one comment is modal does 150 to 200 second with a custom VLLM Docker path on 32B models. Benchmark this a while ago, the warm cold. We're not sure about that, but I mean, we would love to look into that. Yeah, but we can do a 32B model just like we demonstrated now. We can do it in under 1 second. So that is for sure. Yeah. There is a question about how much infra do you have GPU wise? Are you going to run out of capacity? So the whole point here is to use less GPUs, and so right now, we are running about 200 models on a single node. The single node is basically 8 GPUs of H100, and we are able to run 200 models on demand. And these are the models with the spiky bursty workloads, and we are able to manage 200 models. So to answer your question, are we going to run out of capacity? Our entire goal of InferX is to use less GPUs and serve more workloads. So that is exactly the whole entire thesis behind InferX. So you don't need to. We want to make sure the GPU is utilized all the way up to 100%, near 100%. And the biggest problem we believe is the cold start, and we have resolved that problem now. And okay, with that, another question is, Brad, is InferX going to support the offline inferencing as well? Is that possible as well in the future?
Oh, yes, that's in our roadmap. Offline inference, that means user don't need have no clear, no strict that's latency requirement for the result. Because we are serverless platform that and the users online request maybe have spec time, have non-spec time, and there's some GPU will be idle sometime, and we can load the offline inference workload, and then use at that time that means we should use some free GPU to run the offline workload. It will be very cheaper,
Oh,
way
wow.
cheaper than other solution. Yeah.
That's there is no latency requirement for offline inference. So yeah, that's great. And okay, there's a very good question. Actually, this might be the final question, but we'll try. How do you, okay, you're snapshotting loading from NVMe. How do you deal with things that change after the snapshot, like updated weights or dependencies without having to rebuild everything? Oh, that's a good question, actually. When the model gets updated, how are you going to snapshot?
Oh, so far, when the model changed, we have to do snapshot again. That means user have to submit the model and we redo the snapshot. It will take a few minutes.
So a few minutes, basically depending on the size of the model, right?
Yes.
Okay, that's great. So what are we talking about here? How long does a snapshot take? Just for the curiosity, like let's say 32 gigabytes of 32B model.
Yeah, that's a 32B model should be less than 10 seconds. 10 minutes.
10
Yeah,
minutes.
for how long it snapshot will take depends on the model size.
Right.
Yeah, normally normally we will take a longer time than the normal cold start, because we need to do snapshotting. It
Right.
will be maybe 1/2 times of the normal cold start for that model.
And the snapshot is done only one time and then forget about it, and that will be reused
Yes.
forever.
Yeah, snapshot is just one-time work, and if for the multiple node, snapshot only do once. That means multiple node will share one snapshot.
So the same snapshot can be used for scale out as well, right?
Yes. Yeah. For example, if just for a single GPU model snapshot, if user request have burst request and it need use 10 instance to serve that, first that 10 instance share one snapshot, and it need two node, and the two node also uses one snapshot.
Oh, that's interesting. So, okay. So, and also the minimum replica can also be set to 0. We don't need like a minimum replica to 1 or anything like that, right?
Oh, yes, yeah. Your user is okay to set to configure the minimum replica count. If set it to 0, that means that it's go down to 0. No request and there's no resource allocated for this model. If it set to one or more replica, we can consider it's just like a always on service, and
Right.
we support scale out, quick scale out. For example, if you use in memory that's a snapshot, that means for the 32P model, the scale out latency is less than 1 second.
Oh, that's amazing. Okay, we have 1 more minute actually. Can you quickly kiss on how does the scale in and scale out work?
Yeah, actually, user define the how many requests one instance can serve. For example, one instance can serve 10 requests, and our gateway will all the users' requests will go through our gateway, InferX gateway. If InferX detect that there's more requests coming in, more than 10 requests, InferX will start a new instance to cold start another new instance to serve the traffic. For example, if there's 16 requests and one instance can serve 10 requests, that means we use 2 instances to serve that. And all the scale in, scale out is done automatically.
Wow, that's amazing. Well, that's about it, guys. If you would like to try out your own model, we have some free credits for you. Please reach out to us on our Slack channel. If you go to our website, you will see our Slack channel there, and you will be able to deploy your own model with some free credits, and you can try your own model as well. And thanks everyone for joining. Thank you, Brad. Thanks, Jason, for answering the questions and showing the demo. And